Okay. So, hello everyone, I'm Sparsh, and I will be conducting the first hands-on session for the ML track for 30 Days of Cloud. So, today we'll be discussing about the first lab for the ML track for 30 Days of Cloud. That is the performance foundation for data science, ML, and AI tasks in GCP. So, today's session won't exactly be about it won't be about ML as such. It will be more about how you can use cloud along with boost your machine learning models performance, or how you can use the existing tools on Google Cloud. So if so so we'll be doing a bunch of labs today. So namely the AI platform, data prep, data flow, as well as the video intelligence lab. There are some issues with the cloud speech API, so we won't be doing with that. We won't be doing that. We'll be doing the video intelligence lab instead. So yeah, let's get started with the first lab. That's the AI platform lab. So what is this lab about? So you might have noticed that whenever you are training a machine learning model or you're solving any problem, a lot of the times when you're using something like say Keras, TensorFlow, PyTorch, or anything to train your model, it takes really long to train your model. Maybe because you don't have a GPU, or maybe because you have a GPU but it's not good enough. So what you can do instead is you can sort of rent resources on the cloud, as Pranav described in the intro session. And you can basically rent these resources and train your model on these rented resources, and you have to pay for the amount of time which you utilize them for. All right. So this is what this lab is basically about. So it does take a lot of time to initialize the instances. So I've gone ahead and in advance I've made the instances. So anyways, we'll be so the first step would be to open the Google Cloud console itself. All right. I have already done it here. All right. So once you open the Google Cloud platform, once you enter the credentials that are given on Quick Labs and everything, you have to navigate to the AI platform that is available on GCP. So that you can do that from the navigation bar and go to notebooks. As you can see here, I've already created a notebook. However, if you want to create a new notebook, it's as simple as just creating a new instance, select the TensorFlow version with or without GPUs. For the sake of this lab, we'll be doing it without GPUs, but you can always have a GPU for your Jupyter notebook. All right. And once you click on that, it will create a new instance here, and it'll take around 4 to 5 minutes to create an instance. All right. So over here, I've done it in advanced, so you need not worry about it. All right. And yeah, so now we can click on Open Jupyter Lab. And you'll notice that this Jupyter Lab is very, very similar to, your standard Jupyter notebook that you might have used. So let's just give it a while to load. Yeah. So you can notice that this interface is kind of similar to the Jupyter notebook interface. Along with having the notebooks, you can also use some sort of a terminal or something like that. So so we won't be concentrating on the ML part as such, how ML works. So there's an existing example project that is available on GitHub. So we'll be using that. All right. So we can just open up the terminal and we can clone this particular project. Right. Let's just give it a while to clone. Yeah. Okay, so now that the project is cloned, we can navigate to the Python notebook that we are interested in. Okay, so they have created an existing Python notebook for us. So once open this, you'll notice that this is also very, very similar to what you would use in the interface is very similar to what you would use on Jupyter Notebook. All right. So we need not really worry about the first few cells. So those are basically, they have an existing sample database somewhere. They have existing CSV files, and we are just downloading it onto this particular instance, right? So we can just run this. What this particular command basically does is so our sample data set is stored in the location specified by this URL. It basically downloads that particular data set and puts it in a new directory called data. So you can open this data directory and you can notice that it has been downloaded to this place. Then this is again just a command to get so whenever you're training an ML model, you have a training data set and a evaluation data set. So we are just defining those variables here. And yeah, you can just run these. All right. So for example, let's take one of the CSVs. So we'll be using adult.data.csv as specified on top and the adult.test.csv. So yeah, so you can see that the interface is, you can use the CSV to navigate through it, and you can use the same platform to navigate through your CSV and stuff. All right. So this is our sample data. So going ahead. Yeah. So first of all, whenever you are solving any machine learning based problem, the first thing you would definitely do is get a hold of the data set and pre-process that data, right? So, for example, in the CSV, you have multiple columns here, and those can be different kind of columns. So they could be, say, continuous values, or they could be categorical values, where the values belong to a particular set, to a particular predefined set. All right. So here we can see that these are the columns that are available to us in the CSV. For example, this is the age, this is the work class, and education, and all those kind of things. All right. And what the problem we are trying to solve here is predicting the income of a household given all these columns here. So given the age, work class, education number, marital status, occupation, and everything, we are trying to predict what could their possible income bracket be. All right. So whenever we are solving a question like this, there will be some columns that does not really affect our final output. So for example, gender does not really affect what the income bracket will be of a particular person. All right. And so we can basically ignore all these columns, right? And coming to the ones that we will be considering, so something like work class. So it's a categorical variable. That means it cannot have any possible value. We have a predefined set. So the set is specified by the values in this list here, and it can have only these values. It cannot have anything outside this set. And the same for the other variables like occupation, relationship, and stuff. So like, for example, for work class, you can see in this particular column, it has private, local government, never worked, private, but it cannot have any other value outside this set. So moving on, another thing is, like I mentioned, we are not predicting the exact income of the person. We'll be trying to predict the income bracket. So here we have only two brackets, that's less than 50K or greater than 50K. So it'll be sort of a binary classification. All right. So yeah, so now we know what kind of data we are dealing with, what columns we need to use, what we don't need to use, right? Now, since we have this knowledge, we can actually go ahead, download this data set, and clean this data set. So let me just expand this. Yeah. So this particular function does exactly that. It removes all the unnecessary columns, filters out the columns for us, and returns the a new processed data. Download is just a helper function that the pre-processing function makes use of. Okay, same thing. Standardization is something. So whenever you're pre-processing data, you want to have so whatever numeric values you have, suppose you always want to have in the same range. So something like salary might be in the range of, say, from $1,000 to $1,000,000 or something like that. but something like, say, a number of jobs, number of hours the person works or something might range from, say, 10 to 12 or 8 or something like that per day, right? So we want everything to be in a similar range. So we scale down the data using, we basically standardize the data, all right? Um, and yeah. So this step basically uses the previous helper functions to read from the CSV and pre-process this data. We have two data sets. One is the training data and the test data. Test data set, as you know, is the data set that we evaluate on once we are done training the model, right? So yeah, the next step. So now we are done processing the data. We have written functions to read in the data. We are done with processing the data. What would be the next thing? Next, we will be using a neural network. It's kind of overkill here, but let's just take an example of a neural network, because you don't really, because this is somewhere you actually need external GPU or more resources to compute, right? So here we basically define our model. It's a really simple neural network that uses dense layers. And as I mentioned earlier, it's binary classification. So there is one neuron in the output layer, and we use the sigmoid activation function, right? And then we define our optimizer as RMS prop and the other parameters that are needed. So, okay, so now we are done, evaluating our we are done defining our model architecture. We are done with all those things. So what's next? Next is, there are some things that we want from the user. So stuff like how many epochs should we run it for, what should be the batch size, what should be the learning rate, and those are the values decided by the user. So we take these as inputs from the parser, as you can see here, right? And yeah, so now that we have all our parameters, our model, our data, we basically start a training job. So we define a training data set, validation data set, and here we run the keras model.fit. So this basically runs for the specified number of epochs, and it's the same process that you've learned, all right? And it exports it to a predefined directory. So as you can see, it is very similar to what you would do on your local system. The only difference is that since we have more resources here, so if you were to go and check, you can see we have 15 gigs of RAM and four cores of CPUs. Along with that, if you want, we can also have an additional GPU, right? So we need not really worry about allocation of resources and things. So that is basically the advantage of using this platform over your local system or something like Jupyter Notebook on your local system. I won't be running all the cells. Obviously, I don't want to waste your time. It's literally just control. It's just shift enter everywhere. So I am just going to give you a brief overview of what the platform itself looks like. Okay, so that was about AI platform lab. If you have any specific questions with respect to AI platforms, or you face any issues while doing this lab, you can ask that in the comment section, or else we will proceed to the next lab in a short while. Yeah. So I'll just wait for a minute or two in case you guys have any questions, or else we'll move on to the next lab. So yeah. Just going to close these for now. And lab. Yeah. I'll just give you guys a minute, and then we'll start off with the second lab. That is the data prep lab, which is more related to the processing of the data sets. Okay, I guess we have no questions. It was a pretty straightforward lab. So we can proceed to the next lab, that is the data prep lab. All right. So, what is data prep exactly about? All right. So, in the previous lab, you might have noticed that the processing was something very simple, like just filtering out the data, and based on the type of the label, we remove certain columns or certain rows. But what if instead of having to code all this out, what if we could use some neat GUI like interface to do the same thing? All right, so that is what data prep is basically about. Instead of having to write code for it, you can just use the simple something like your Google Sheet kind of an interface, but for data science. All right. uh, just a second. Yeah. Right, so just give me a minute. We'll set up and we'll enter the credentials and set everything up. Okay, so now we are okay, let's just wait a second for this. Yeah, so first first we have to go to the store to use the data prep platform. We have to go to storage. Just a second, guys. Yeah, so let's go to the storage section. Yeah, and we have to go to the browser. Right, so here we can, so if we want to create a flow, we have to be storing a data set somewhere, right? So we'll have to download the data set and then store it in some sort of a storage unit, and then do whatever processing you want to do on it. So this storage unit is basically called a bucket on GCP. So we can create a bucket, right? Let's call it example bucket 100. Okay, it's probably taken. It should just be a unique name. So I'm just going to say ML1, something like that. All right. You can continue, and yeah, you can just select the defaults here. You need not really worry about this. Okay, so I've created a new bucket. Now all right. So now that I've created a bucket, I go back and search for the data prep field. Right. Let's just give it a minute to load. Yeah. Meanwhile, if you have any questions, you need not wait till the end. You can immediately ask in the comment section. We have a lot of buffer time between the initialization of instances and entering the credentials and stuff. So yeah. So yeah, we can give permissions. Yes. Yeah, okay. So yeah, that took a while, but anyways, now we have created a bucket, so we know where we want to store the data, right? So whenever we want to process the data, we have to create something called a flow. So I'll explain what a flow is exactly. Let's create an example flow. Um, right. Let's just copy and paste the name from the quick lab. Click and create. Yeah. Okay. So we can click the help, or we can skip the helpers, right? So now we have created a flow. Uh, Now we have flow is basically it shows a step-by-step procedure of what you're filtering out in each step. So suppose I have a data set and I want to remove certain columns. So the first step of a flow might be to remove specific columns, and the next step might be to filter based on a particular range of values and things like that. So here we want to add a data set. So we have multiple options. Either you can upload from your local system. So if you have a CSV file or something like, or a TXT file saved on your system, you can upload from there, or you can use something that is already uploaded to the Google Cloud Storage, or you can use a Google Sheets or CSV or anything else. All right. So we'll be doing it from Google Cloud Storage. We have an example data set that has been uploaded for us. That's the election data set, if I'm not wrong. Oh, my bad. Right. So, yeah. So we'll be using two files over here. One of them is this one. This is the candidates file, all right, for the elections. And the other one is the campaign contributions file. That is this. Right. Sorry. All right. So now we have to process two data sets. We have added both of them to the flow, right? So let's wait for it to create the flow. Right now we have added both the data sets to the flow. What's the next step? Next step is, suppose we want to process only this data set. Okay, so we can click on this, and we can create something called a recipe. A recipe is basically an individual step in a particular flow. So all right. And once we've created this recipe, at this particular moment, this and this particular recipe will be the exact same copies. So if you want to make any changes to this recipe, we can do it. Right. So click on the edit recipe button here. And you'll notice, okay, this will take a while to load. But once it loads in, you'll notice it opens a similar interface to your Google Sheets or your Microsoft Excel or something like that. All right. And along with that, you will have other analytics available as well. So let's just wait for it to all process. Yeah. So over here you can see not only do you get the values like you would get in a normal spreadsheet application, you also get, so suppose this particular column has categorical variables. You can also view what are the different categories, what is the distribution of each category. So for example, in column 4, we can view that REP is the most occurring category. Similarly, for the year, we can also view the distribution of various years in this case. All right. And if you want to restrict something to a particular data type, you can do that using this flag variable as a drop down. Apart from that, suppose, so now that we have the column 6 open, we want to know more insights about the rows which have values as US here. All right. So you can click on it, and it does not do that in this case, but you can normally have different variations of a particular value. So it could have been, say, USA, it could have been smaller case US or something like that, and it will recognize all those patterns here. All right, and if you want to filter out on the basis of this, you can just click on keep rows, and it will automatically filter out all the rows where the column 6 value is US without you having to actually write any sort of code for it. All right, so that is the basic things. So with respect to what is there in our lab, for example, let's view column 5. All right, so what we basically want to do here is we want to keep all the columns where the values are between 2016 are during 2016 and 2017. So what you would normally do in an ideal scenario is you would load it up in your Jupyter notebook and import pandas, then load in the data frame, and then filter out the values based on this column. But instead of doing that, we can just load it up in data prep, click on edit. All right, and here we want to keep only between 2016 and 2017, right? So we can just edit the years. Sorry, 18. So that is before Jan of 2018, and you can select keep matching rows. Yeah, once you click on this, you can see it has filtered out all the columns. All right, so only 2016 and 2017 are present. All right, so if I were to scroll down a bit, yeah, only 2016 and 2017 are present, and all the other values have been filtered out. And this can be easily done with the help of the GUI tool that is available. Now, if we want, each recipe need not have only this one step. You can have another step where you maybe filter out on the basis of another column. But for simplicity, we'll just restrict it to one particular column. All right. So we have created a recipe. Now we want to run it. All right, so we can click on run job. And yeah, it will just start running a job where it tries to, yeah, actually it has already processed it. Damn. View details. Yeah, so the job is still in progress. So after a while, you can actually check it, and you'll notice that all the columns that we specified here have been actually filtered out. So that is sort of an introduction to the data prep platform on GCP. You can always using Quick Labs, you can always try out other exciting stuff on data prep, and you can practice on your own. But that is it for data prep. If you have any questions related to data prep, you can ask in the comment section. Yeah, we'll wait for another 2 or 3 minutes, and then we will start off with the next lab. If you have any questions, please feel free to ask them in the comment section. This is not so. This is so there are two different tracks. There's a cloud track and there's the ML track. Both the quests have one particular skill, one quest in common. That is more oriented to the cloud. All right, so that they are sort of explaining it in the cloud track itself. And specific to ML, this is the first track. Yes. Okay, so I guess no questions again. Only one question regarding which quest it was. So we can move on to the third lab for the day. That is the data proc lab. So this is a pretty short lab. There's not much to do here. So I'll start the lab and explain what this is about exactly. Yeah. So in the previous two labs, we noticed that whatever we did was very, very specific to machine learning and things like that. But what if you want to run something else apart from machine learning? Suppose you have some Python file that, for example, say evaluates an approximate value of pi or something like that, and and we are doing some sort of say parallel computation, so we want to run it on the cloud and not run it on a local system. Okay, so instead of for that, we have a platform called DataProc on GCP that you can use. So just give me a second. We'll open it up. Okay. Just a second, guys. Okay, so for this particular lab, we'll need changes in a few user permissions and stuff. So you can go to navigation menu and IAM section. So here you can see all the users that have access to this particular project. All right. So here Quick Labs actually creates a project for us, right? So we can view who and all which accounts have access to this particular project. All right. And most of them are Quick Labs related and GCP related accounts. However, we want to find the account specific to us. All right. So we will actually create a new new account. So let's copy the project number. It should just be a unique number. It need not be, yeah. Again, it's not the project ID, it's the project number. Please remember that. Okay, just a second. Okay, there seems to be some issue here. Yeah. Okay, so we will need the role of editor here. Okay, there seems to be some issue with respect to the account that we have added. Okay, just a second. Okay. Yeah. Right. So here's the thing. For project, we'll need the editor role. And okay, this member already exists for us, so we need not worry about it. All right. Cool. So yeah, we can. So now we'll be using something called the data proc platform, as I mentioned. So we have to go to the library and enable the Dataproc API first to be able to use it. It has been enabled for us by default, so we need not worry about that. All right. So anyways, let's get started with the main half. So before we create a particular job, we have to create something called a cluster. So a cluster is basically where a job will actually run. All right. So yeah, let's go to navigation menu, Dataproc. Let's search for the no Dataproc section. Where's Dataproc? Yeah, Dataproc clusters. Okay, and we will have to create a new cluster here. All right. So and let's just initialize it with the parameter specified in quick labs. Okay. Region, yeah, all this is fine. Region should be set to global. Okay, and yeah, you can create the cluster. So if I were to go here, it will take a while. It'll take around a minute or so to create a cluster. So while we're creating, so we know where we want to do the computation, all right? So now we have to decide what we want to compute. So that will be defined in the jobs section of Dataproc, right? So we won't be writing any custom job here. We have an existing job that calculates the value of pi using Dataproc. So we'll be using that itself. So we create a new job. Job ID can be anything. Region global example cluster is the one that we created before, and we'll be running in this on with a framework known as Spark. It's a big data framework that requires an entire separate seminar to explain what it does. So I'm not going to be going in the details of it here. And we'll be like I told, we'll be using a pre-existing program. So this is an existing program written in Java that basically calculates the value of pi using Apache Spark. So it's like one of the Hello World programs of Spark, something like that. Really specifying the arguments and the jar file. So this jar file is something like, think of it something like an executable that will run the actual, that will run after the Java program has compiled, right? We can submit the job. Close this. Right, I'm assuming that the cluster is done initializing. Yeah, okay, so yeah, so the job is running. We will have to wait for about a minute for the job to finish. Right. Yeah, you can just keep refreshing around after every 10 or 20 seconds and check if it has finished or not. Okay. It's taking quite some time to actually finish up. Right. Should I go to the job section? Oh yeah, my bad. We were supposed to be checking the job section for the output. So you can see here that the job has succeeded. And if you want to view the output, you can go to the output section, and it has calculated a rough value of 3.1418. Well, it's correct up to the first three decimal places, so that's great. So this is a very simple program that can be used on the Dataproc platform to run a job. You can obviously run more complex jobs using more complex frameworks on Dataproc. But yeah, this is sort of an introduction to what it can do and what it is about. So if you have any specific questions with respect to this, you can always ask in the comment section, or else we will move on to the next lab in a few minutes. So yeah, I'm just going to close this and wait for any questions. Okay, I guess there are no questions in the comment section. Okay, so I'm just going to go ahead and proceed to the next lab. So it was in the event details, it was mentioned that we will be doing the Google Cloud Speech API lab today, but there seems to be some issues with this lab. And till it's fixed, we don't know when it'll be fixed actually. So we'll probably do the video intelligence lab instead. So this is basically about how if you have a particular video, you can annotate it with labels, the specific duration. You can take those durations and label each part of the video. All right. So if you're building any, say, you consumer products or something, it is very common to use some sort of a speech API or labeling or something like that. And instead of building your own model from scratch every time, you can use this existing function APIs that are available from GCP. So if you have, say, a audio clip or something, and you want to know what the text is in it, you can. You can just send a request to the GCP API, and you can find it out instead of training your own model. Similarly, you can do the same thing for video as well. Instead of training your own model for uh, labeling and annotating the video, you can use an existing model that is present on GCP using these APIs. All right, so we'll just start the lab. It's a pretty short lab. It'll take hardly around 10 to 15 minutes. All right. So, okay. Just a second. We just enter the usual credentials here. Okay, so before we start using the APIs over here, so as in the previous lab, you noticed that we can change the users that have access to a particular project, right? So similarly, we'll be creating something called a service account, and we can give access to this particular service account. We can give access to this particular project to only that service account, all right? And you can use these service accounts to create API keys for us. Let's just wait for the the shell to allocate resources for us. Yeah. So once you're done with this, so the first step is to create a service account. So for that, you can, yeah, we'll create an account named Quick Start, right? We have to authorize for this to use. All right. Now, once we are done creating the service account, we have to create some sort of key using which we can access the API. So it'll be some sort of a unique ID, which when sent, GCP will know that, this particular account is trying to access it. So and we will be storing this in a file called key.json, all right? Quick start. And you can enter your project ID here. Service account.com. I'll just increase the font size a bit here. Yeah, I hope it's visible to everyone. So over here, you're basically specifying that you want to generate a key and store it in a file called key.json. And the account that will be using to generate this is quickstart at your projectid.im.gserviceaccount.com. That's basically the account that we created in the previous step, right? There seems to be some, let me try that out again. Oh, sorry, it's keys create. So, and like I told, we'll be creating the key. So we have to, right? Yeah. So what this basically does is it creates, if you'll notice, it creates a file called key.json. And if we were to output the content of key.json, do not share the content of this key.json ever. Over here, it's a quick lab, so that's fine. But over here, you can see it's a unique key that stores all your data and your email ID and everything of that sorts. Okay, so now that we are done creating this key, we have to create something called an access token. So this at the end of the day, this access token is what you will send with your, whatever HTTP request you send to GCP to gain access to this model. All right. So I can create an access token using this, and then I can print it out. So this will be our access token that we'll be using. You can copy and paste it if needed. All right. So next, in whatever request we send, we'll have to specify what file we want to process and what action we want to process, what action we want to perform on it. All right. So we'll create a file called request.json. And you can copy in the content from QuickLab itself, not type it on your own. So here, again, there's a file uploaded on GCP, on Google, Google file storage on this particular location. And what we want to extract is, we want to do label detections and annotation of this particular file, all right? And now we can use something like curl to send a simple HTTP request. Right. So we are specifying the content type and all those stuff. And this is the URL that we'll be sending the request to. So here, this is the API domain. And here we are saying we want to annotate the video, right? And using this will create a project on the Google Cloud Platform. To copy this ID. Okay, and you can send it along with the next request. So yeah, here it'll take a while to process this. So I'm not going to be waiting for the end result. So basically, once this is done processing, you'll have your input time and your start time and your end time when the job is done. Along with that, the output is available on QuickLab. So I'll just explain that to you. Right, so you can see, so this is the output that we have been getting now, right? So once the job is completed, you can keep running the same command again and again to get to see whether it's completed or not. It will basically output an array of segments. Each array will contain what entity it has, and what time it starts and what time it ends, and what is the confidence value with which it predicted that this segment implies this. All right. So you'll just have an array of that. And using this, you can use the Cloud Video Intelligence API to annotate your videos. If you have any questions related to this, feel free to ask in the comment section. Yeah, I'm going to wait for a minute or two. If you don't have any questions, we will wrap up the session for this week. Yeah. If you have any questions, if you face any issues in other labs, other quests, or even if you face any issues in the first quest that was there, some people were talking about it in the comment section. Even for that, you can ask any questions if you want. I'm going to end this lab right here. Yeah, so we have covered these 3 labs today, these 4 labs: AI platform, data prep, data proc, and the video intelligence lab. Once you're done with this, you can feel free to try out the challenge labs for each quest. So challenge lab basically tests your understanding of the concepts in the lab for that particular quest. So I won't be doing this lab. I'll just roughly skim through it. So as you can see, you have 4 tasks that are related to data proc, data flow, data prep, and your the video. It's one of the 3 APIs. Either you can use the speech API or you can use the video intelligence API that I used in this particular demo. So if you have any questions with respect to the challenge lab as well, you can ask in the comment section. Okay, it looks like there are no questions. So I'm assuming everyone got enough time to complete this lab. So you have probably finished the challenge lab as well. So, okay, if you don't have any questions, I guess we can wrap it up. And during the next session, we will discuss about the next one or next couple of labs that we have for this track. So till then, I guess that is pretty much it. We will wrap it up now. So see you guys. Bye bye.